Welcome to the deep dive. Today we're jumping into something huge, artificial intelligence, AI, and how it's really changing the game in cybersecurity.
It really is.
And this isn't just, a general chat. We're digging into the specific articles, the research, all the notes that you, our listener, actually sent over to us.
That's right. So the plan is to unpack all that material you provided together. We want to really get at what AI means for, well, both sides, the attackers and the defenders.
Right, and this whole AI arms race thing that keeps coming up.
Exactly. And look ahead a bit, especially towards things like Infosecurity Europe 2025, which your sources seem to really focus on as a key moment for these discussions.
So think of this as us helping you cut through the noise, focusing right in on the crucial bits, the surprising facts, all grounded in the stuff you gave us. Let's get started.
Okay, let's do it. So the sources you shared dive right into the basics. What is AI? Fundamentally, it's about computer systems doing tasks that, well, normally need human intelligence. Things like seeing, recognizing patterns, understanding language.
And machine learning, ML, is a big part of that, right? The sources mention Samuel's definition from way back in '59.
Yeah, the idea that computers can learn without being explicitly programmed for every single task. That's the core. And for cyber, its power is handling just immense amounts of data.
Network logs, endpoint activity, threat feeds. It's just too much for humans alone.
Absolutely. ML finds the patterns in that ocean of data, patterns humans might never spot. Your material highlights a few key types. First, supervised learning.
That's learning from labeled data, like this is bad, this is good.
Exactly. You train it with examples. So it's good for classifying known malware types or, say, spotting a DDoS attack that looks like ones it's seen before, like teaching a kid cat with labeled pictures.
Okay, recognizing the known stuff, but super fast.
Precisely. Then there's unsupervised learning. This is different. It finds patterns in data that hasn't been labeled.
Ah, so this is for finding the unexpected, the new stuff.
That's the sweet spot. It's really valuable for anomaly detection spotting behavior that's just weird, deviates from the norm. That's how you can potentially catch new attacks, 0 days, things nobody's cataloged yet because they look different.
Finding the unknown unknowns, yeah. What about reinforcement learning? That sounds different again.
It is. It's about learning through trial and error.
Yeah.
An AI agent tries things, gets rewards or penalties, and learns to maximize its success over time.
Like training a dog with treats.
Kind of, yeah. In security, your sources mention using it for things like simulating attacks to test defenses, building defenses that adapt on the fly, or even training AI agents for cyber operations. Learning by doing.
And semi-supervised is just a mix, when labeling everything is too hard.
Right, a hybrid approach. Good for things like identifying malware or bots where you might have some labeled examples, but tons of unlabeled data.
Okay, makes sense. Beyond the learning types, what specific AI tech are we talking about? Neural networks.
Yeah, neural networks, or ANNs, are foundational. Inspired by the brain, they learn complex patterns, and they're the basis for deep learning, DL.
Deep learning uses networks with lots of layers, right, to tackle really complex stuff.
Exactly. Those layers let it learn hierarchical representations of data. It's super powerful for advanced malware detection stuff that changes its code network intrusion detection, sophisticated phishing analysis, even finding software vulnerabilities.
Why is it so good for those?
Because it can handle massive data sets, spot really subtle patterns indicating unknown threats, and it can adapt as threats evolve. Its depth allows that complexity.
Natural language processing, NLP, also comes up a lot. Understanding human language.
Crucial in cyber. Think about analyzing phishing emails, not just the links, but the language used. Is it trying to create urgency? Is the grammar perfect, maybe too perfect? NLP helps with that.
I'm pulling info from reports and stuff.
Right? Extracting threat intelligence from news articles, blog posts, dark web forums, anywhere humans are writing about threats. Also automating the analysis of security logs. Your sources point to Google using TensorFlow NLP for Gmail spam detection. It works.
And then, the big one, generative AI.
GenAI. Ah, yes. GenAI, creating entirely new content, text, images, code, things like ChatGPT, JANs. This is a huge deal, as your sources stress, because it's so profoundly dual use in cybersecurity.
Dual use how?
Well, offensively, attackers are using it to generate incredibly realistic phishing emails, voice clones for phishing, deepfake videos, even unique malware code on demand. It's a massive upgrade for them.
Okay, that's the scary side. What about defense?
Defensively, GenAI can create realistic simulations for training security teams, help analysts identify potential vulnerabilities in code, automate parts of incident response reporting, or assist in malware analysis. It's fundamentally changing social engineering and malware creation.
Wow. Okay, one more key tech mention, explainable AI, XAI. Why is that important?
Trust. Plain and simple. If an AI flags a critical alert or blocks legitimate traffic, the security team needs to know why. XAI aims to make AI decisions transparent, to open up the black box.
So analysts can understand and verify what the AI is doing.
Exactly. It builds confidence and enables that crucial human-AI teaming. You can't just blindly trust a black box with critical security decisions.
Right, so that's a good map of the AI tools in play from your sources. Understanding the tech is one thing. Now, how is it being used as a weapon?
Okay, let's shift to the offensive side. The sources are clear. AI is a massive force multiplier for attackers.
Force multiplier, meaning it just makes them better, faster.
Much better, much faster, and at a much larger scale. It automates tasks that used to be manual and time-consuming, like reconnaissance or crafting phishing emails. It increases the speed, the volume, and the sophistication of attacks, and it helps them evade detection.
And the NCSC prediction you mentioned.
Yeah, your sources quote the UK's National Cybersecurity Center saying AI will almost certainly increase the volume and impact of cyber attacks in the near term, mainly by making existing attack techniques more effective.
And it makes it easier for, well, less skilled attackers.
That's a major concern highlighted. Publicly available AI tools or things sold on the dark web like Fraud GPT, which apparently helps craft phishing emails and malware, they lower the barrier to entry.
So someone without deep technical skills can launch fairly complex attacks.
Potentially, yes. This likely fuels things like ransomware, making sophisticated capabilities available to a wider range of criminals, hacktivists, you name it.
Okay, easier, faster, more sophisticated. Let's walk through the attack stages. Reconnaissance, finding targets.
AI turbocharges this. Think automated OSINT open source intelligence gathering. AI can scan social media, websites, data breach dumps, everything public incredibly quickly.
To build profiles of targets.
Detailed profiles. Finding high-value assets, key employees. Maybe spotting someone susceptible to social engineering based on their posts. It can map relationships between systems, identify potential entry points, and it can do this slowly, subtly, potentially flying under the radar of detection systems.
Wow. And finding actual vulnerabilities, like 0 days.
AI is accelerating that, too.
Yeah.
AI-powered fuzzing tools can probe software for unknown flaws. Your sources mention tools like Vonehunter using LLMs to find and explain complex, multi-step 0 days in hours, not weeks or months.
In hours, that's fast.
Incredibly fast. AI can also automate analyzing code or configurations for weaknesses. And it helps prioritize which vulnerabilities to target first, using threat intel alongside the technical details. The SANS course mentioned, SEC 535 on AI pentest assistance, shows this is becoming mainstream offensive practice.
Okay, so finding targets and holes gets a massive AI boost. What about actually building the malware?
This is where things get really interesting and, frankly, worrying. Your sources talk a lot about AI-generated polymorphic and metamorphic malware.
Polymorphic changes its appearance. Metamorphic rewrites itself.
Exactly. And AI, especially generative AI, makes creating this kind of evasive malware much easier and more effective. Models can be trained to produce unique, adaptable malware code basically on demand.
So each version is slightly different.
Or significantly different. It can change its structure, its encryption, even its core behavior, making it incredibly hard for signature-based defenses to catch. Think dynamic code obfuscation, adaptive attack vectors. One study mentioned from Unit 42 showed LLMs rewriting malware specifically to bypass detection by other AI models and even VirusTotal.
So AI is being used to defeat AI defenses.
That's the arms race right there.
Yeah.
And AI also helps develop the exploits needed to deliver the malware and obfuscate the final payload.
How does it help develop exploits?
By analyzing vulnerability data, comparing software versions patched to pinpoint weaknesses, and even suggesting or generating exploit code. Some AI agents might even find and generate exploits before they're publicly known.
And hiding the malware.
AI can help ghostwrite payloads based on known frameworks like Metasploit's Interpreter, making them look familiar but subtly different. Or use AI-assisted techniques to make the malware blend in with normal system activity, trying to fool EDR tools. The NCSC view again. AI could generate novel malware that evades current filters if trained well.
The weaponization side is deeply concerning. How does AI change the delivery? Social engineering seems like a prime target.
It absolutely is. AI enables hyper-personalized social engineering at scale. Your sources cite a really shocking statistic, a 10,265% increase in AI-powered phishing, vishing, and smishing since late 2022.
1,200%, that's insane.
It reflects the impact of readily available GenAI tools. AI can scrape public data, LinkedIn, social media to craft incredibly tailored messages. They sound legitimate, reference real projects or colleagues, mimic writing style.
Making them much harder to spot than generic phishing emails.
Much harder. NLP ensures the grammar is perfect, sentiment analysis can be used to manipulate emotions, and then there's voice phishing.
Using AI to clone voices.
Yes, AI voice synthesis can create scarily accurate clones from just short audio samples. Imagine getting a call supposedly from your CEO asking for an urgent wire transfer, and it sounds exactly like them.
That's terrifying. The sources mention the FBI warnings?
They do. Warnings about deepfake calls impersonating officials. And that stat, 37% of organizations apparently already hit by voice deepfake scams, shows it's not theoretical. Hybrid attacks are also emerging, maybe an SMS followed by a deepfake call.
And visual deepfakes, videos and images.
Also a major threat, created using tech like JANs. They can convincingly swap faces, manipulate expressions, fabricate entire events or statements. Used for high-stakes fraud, at that Rupp case again, $25 million lost to a deepfake video call impersonating the CFO.
Wow.
And also for disinformation, creating fake videos of politicians or competitor executives to damage reputations or sway public opinion. Another area the FBI is actively warning about.
So AI makes the bait look, sound, and read perfectly. Once they get a foothold, does AI help with the actual exploitation?
Yes, AI agents can automate parts of the exploitation process. Things like Shell GPT are mentioned for automating SQL injection attacks by analyzing web code. And once inside, AI can automate post-exploitation tasks, moving laterally through the network, finding valuable data, exfiltrating it.
The Morris test malware example fits here.
Exactly. An early example using self-replicating prompts to basically weaponize GenAI email assistants themselves, making them steal data or send spam, automating the spread and impact.
Which leads into command and control, C2, and what attackers do once they're in.
AI changes this too. It can allow malware to operate more autonomously, using legitimate tools already on the system living off the LAN. This reduces the need for constant chat back to a C2 server, making it harder to detect.
Less noise for defenders to pick up on.
Right. AI can also generate fake network traffic, chaff, designed to look like legitimate activity, or even mimic other attacks to confuse defenders and hide the real C2 channels.
And the malware itself can adapt, learn inside the network.
That's a key capability. AI can enable malware to learn from its environment in real time. If it encounters a defense, it might try a different technique. It can dynamically change its behavior or payload based on what it finds, making it much more resilient and evasive.
And when it comes to the final goal, like stealing data or ransomware?
AI can help maximize the impact. For data theft, AI could analyze the exfiltrated data to quickly pinpoint the most sensitive or valuable information. For ransomware, AI could automate the process of identifying critical systems to encrypt first, or dynamically adjust the encryption process to cause maximum disruption and pressure.
Okay, the picture of AI enhancing existing attacks is pretty grim, but you mentioned a newer threat, attacks on the AI systems themselves.
This is becoming incredibly important as defenders deploy more AI. One major attack vector is data poisoning.
Poisoning the training data.
Exactly. Intentionally feeding the AI bad data during its training phase. This can subtly bias its decisions, make it misclassify things, or even create hidden backdoors. Imagine training a medical AI on images where cancerous tumors are deliberately mislabeled as benign.
That could have devastating consequences. Are there real examples?
Your sources mention one from February 2024 where malicious code payloads were found hidden within machine learning models hosted on Hugging Face, a popular platform for sharing AI models. Someone could unknowingly download and use a poisoned model.
Undermining the AI from the very start. What about after it's trained?
Then you have adversarial attacks or evasion attacks. These involve crafting specific inputs, often with tiny, imperceptible changes, designed to fool a trained model.
Like the example of changing a stock sign image slightly so the AI sees it as something else?
Precisely. Or modifying a piece of malware just enough, maybe adding some junk code so that an AI detection engine, even when trained on smaller malware, fails to flag it. It exploits the way the AI has learned to make decisions.
Okay. And stealing the model or its data?
Two types here. Model inversion tries to reconstruct the sensitive training data by analyzing the model's outputs or behavior. This could potentially leak private information used during training. Model stealing is about trying to replicate a proprietary AI model, maybe by sending it lots of queries and observing the responses, essentially stealing the intellectual property.
Who would target these?
Competitors, criminals wanting to bypass a specific AI defense, nation-states, anyone wanting to undermine or copy valuable AI systems, especially those offered as cloud services or APIs.
And finally, prompt injection. That's specific to LLMs like ChatGPT.
Yes. It's about crafting malicious input prompts to trick the LLM into ignoring its safety guidelines or original instructions. You might try to get it to reveal confidential information it holds, generate harmful content, or even execute code or interact with other systems in unauthorized ways.
How does that work?
Sometimes you can trick it by embedding hidden instructions within a seemingly harmless prompt, or by trying to reverse engineer the system prompt that guides the LLM's core behavior, looking for weaknesses to exploit.
So AI isn't just a tool for attack. The AI systems themselves are becoming targets. That's a whole new layer of complexity.
It absolutely is. But, as your source title suggests, it's a double-edged sword. Let's flip perspective now and look at how AI is being used powerfully for defense, the resilient shield.
Right, because organizations aren't just sitting ducks. They're using AI to detect threats faster, automate responses, predict problems, and generally strengthen their security.
And the core defensive advantage mirrors the offensive one. AI's ability to process mind-boggling amounts of data in real time, spot subtle signals humans would miss, and react at machine speed.
So let's talk detection, finding those hidden threats. Anomaly detection is key here.
Definitely. AI, especially unsupervised learning, is fantastic at building a baseline of what's normal for your specific environment users, servers, network traffic applications. Then it flags significant deviations.
Like a user logging in from a weird place at 3 a.m.
Exactly. Or accessing files they never touch. Or a server making unusual outbound connections. These anomalies could indicate a compromised account, insider threat, or even a zero-day exploit that doesn't match any known signature. Your sources mention Dark Trace's approach here, learning the organization's unique pattern of life.
And behavioral analysis, UEB and NTA.
User and Entity Behavior Analytics, UEB, uses ML to specifically analyze user and device behavior patterns to spot risky actions that might indicate compromise or malicious intent. Network Traffic Analysis, NTA, does something similar but focuses on network flows, looking for things like command and control traffic or data exfiltration patterns.
There's also AI-driven behavioral biometrics.
Yes, that's interesting. Analyzing how a user interacts their typing rhythm, mouse movements.
Yeah.
It adds another layer to authentication, especially in zero-trust models. If someone's logged in but their interaction patterns suddenly change drastically, it might indicate their session was hijacked.
Malware detection gets an AI boost too, beyond just signatures.
Oh, significantly. Deep learning models are much better at catching novel, polymorphic malware that constantly changes to evade traditional AV. Instead of just looking for known signatures, AI analyzes the file's characteristics, its behavior when executed, in a sandbox perhaps, its code structure, looking for malicious indicators.
Like the CrowdStrike or Sentinel-Alone examples, detecting ransomware behavior.
Right. They use AI to spot behaviors like rapid file encryption across many files, a classic ransomware symptom, and can then automatically isolate that machine to prevent the infection from spreading, much faster than relying on a signature update.
And phishing detection. We talked about AI generating better phishing, but it helps detect it too.
Yes, thankfully. NLP and deep learning analyze incoming emails, looking at the content, sender reputation, link URLs, even the writing style and tone to identify sophisticated phishing, spear phishing, and business email compromise attempts that might trick a human.
Like the Gmail and Microsoft Defender examples you mentioned earlier, analyzing how it's written.
Exactly. They're learning what AI-generated scam emails look like. Hybrid models combining different AI techniques are showing high accuracy rates. Your sources mentioned 97.5% in one case, and they can adapt quickly as attackers change tactics.
And what about fighting deepfakes? Is there defensive AI for that?
There is, yes. It's an active area of research. AI models, often using things like convolutional neural networks, CNNs, are being trained to spot the subtle inconsistencies often present in deepfake video or audio.
Like weird artifacts or unnatural blinking?
Things like that, yes. Or analyzing lighting inconsistencies, background details, voice patterns, frequency spectrums. Techniques like error level analysis can sometimes spot image manipulation. It's currently more promising for video and audio than for synthetic text or images, but your sources rightly cautioned it's not foolproof yet. The detectors are still playing catch-up.
So AI helps see threats in real time, but security needs to be proactive too. How does AI help predict or prevent issues?
This is a really exciting area. AI enables predictive analytics for vulnerability prioritization. Instead of just reacting to vulnerabilities as they're discovered, AI can analyze historical data, current threat intelligence, and your specific IT environment to predict which vulnerabilities are most likely to be exploited in your context.
So it's not just about the CVSS score.
Not just that, AI can quantify the actual risk based on exploit likelihood, the importance of the affected asset to your business, and compensating controls you might have. Your sources mentioned Rapid7's exposure command using AI for this kind of risk scoring. The idea is to focus remediation efforts where they'll have the biggest impact.
Potentially saving a lot of time and effort chasing less critical vulns.
Exactly. Reducing time to fix for critical issues by up to 70% according to one source. And then there's AI-assisted threat hunting.
Pairing human intuition with AI's data processing power.
Precisely. Threat hunting is proactive searching for threats that might have slipped past automated defenses. AI can massively accelerate this by sifting through enormous data sets, logs, network flows, endpoint data identifying subtle anomalies or patterns that warrant human investigation.
So the AI surfaces potential leads for the human hunter.
Right. It connects dots across different data sources, highlights suspicious correlations, and significantly narrows the search space, making human hunters far more efficient. Darktrace's cyber AI analysts cited again here, investigating alerts automatically and presenting summarized findings, supposedly cutting triage time by 92%.
That leads nicely into incident response and the SOC. AI seems poised to revolutionize that.
It really is. The sheer volume of alerts SOCs face is overwhelming. AI excels at automated alert triage and prioritization. It can filter out the noise, identify false positives, and bubble up the truly critical alerts, reducing analyst fatigue and speeding up response to genuine threats.
And so platform security orchestration, automation, and response are getting smarter with AI.
Yes. AI infusion makes OSAR platforms more intelligent and adaptive. They can go beyond simple predefined playbooks to make more context-aware decisions about automated actions like isolating an endpoint, blocking an IP, quarantining a user account, or triggering the right response sequence based on the specifics of the threat.
Your sources mentioned a step beyond SOAR, agentic AI and AI SOC analysts.
This is the cutting edge. Agentic AI involves semi-autonomous AI systems working on tasks. AI SOC analysts are envisioned as AI systems that don't just follow playbooks, but can autonomously investigate alerts, correlate data, decide on next steps, adapt their techniques, learn from outcomes, and even generate human-readable reports.
So less pre-programming, more independent analysis.
That's the idea. IBM's ATOM project is exploring this agentic framework. Dropzone AI, mentioned in your sources, argues these AI SO analysts could handle much of the Tier 1 investigation work more effectively than traditional SESAR, which Gartner apparently projects might become obsolete.
AI even helps after the incident, during forensics.
Yes. Digital forensics involves analyzing vast amounts of data from compromised systems. AI can accelerate this, dramatically identifying malware artifacts, tracing attacker timelines, finding indicators of compromise across multiple systems, even parsing logs and communications using LLMs, finding the root cause, and gathering evidence faster.
Okay, so AI is a powerful shield. But just like attackers target defensive AI, defenders need to protect their own AI tools, right? Securing the protectors.
Absolutely critical. If your AI defenses are compromised, you're in big trouble. This involves proactive measures against those attacks we discussed earlier.
Like defending against data poisoning and adversarial attacks.
Yes. Techniques include rigorous validation of training data, using diverse data sources, implementing anomaly detection for inputs and outputs of the AI model, and something called adversarial training.
Training the AI on malicious examples.
Essentially, yes, you deliberately expose the model to adversarial examples during training so it learns to become more robust against them.
And protecting the models themselves from being stolen or tampered with.
Protecting model integrity and confidentiality is key. This involves using techniques like differential privacy, adding noise to data to protect individual records, federated learning, training models locally without centralizing raw data, secure multi-party computation, encrypting models, tightly controlling API access, and monitoring for signs of model stealing or inversion attempts.
And explainable AI. XAI comes back into play here too.
Crucial for the defenders, XAI allows the security team to understand why their AI tool made a decision, increasing trust, enabling validation, and facilitating effective human oversight and collaboration. You need to be able to audit and understand your AI defenses.
So AI offers a really powerful defensive toolkit from detection to response to prediction, but it needs its own protection. This constant back and forth really underscores that idea of the AI arms race.
It's the central theme emerging from your sources. This isn't a static situation. It's a dynamic, competitive cycle. Attackers develop new AI-powered techniques,
Defenders respond with AI-powered defenses.
which prompts attackers to find ways around those defenses, often using AI again.
Yeah.
It's this continuous loop of innovation and counter-innovation. And agentic AI, with autonomous capabilities on both sides, just pours fuel on that fire.
What are the key dynamics driving this race right now?
On the attacker side, it's rapid adoption. They're using AI to make existing attacks faster, more scalable, and way more sophisticated. We talked about AI-generated malware adapting on the fly using LLMs, hyper-personalized social engineering with deepfakes, automated vulnerability discovery finding 0 days quicker.
And empowering smaller players.
Right, scaling operations that previously required significant resources. Meanwhile, defenders are deploying their own sophisticated AI for real-time detection across massive data sets, building adaptive security systems that learn and adjust, automating incident response for speed, and using predictive analytics to try to get ahead of attackers.
It sounds exhausting, frankly. The big question everyone asks, who's winning? Does AI currently favor the attacker or the defender?
Yeah, your sources grapple with this, and the consensus seems to be it's complicated. There's no simple answer. AI gives advantages to both.
What's the argument for the offense having the edge right now?
Several points. Lowering the barrier to entry means more attackers with better tools. The sheer speed and volume of AI attacks can overwhelm defenses. Offensive innovation, sometimes using open source models, might be happening faster than defenders can integrate complex systems. And potent new weapons, like adaptive malware and deepfakes, are hard to counter. The NCSC view echoes this near-term increase in attack volume and impact.
Okay, and the case for the defense.
AI lets defenders analyze data and detect threats at unprecedented scale and speed, potentially stopping attacks much earlier. Automation frees up scarce human expertise for high-level tasks. Proactive hunting and predictive vulnerability management offer a chance to get ahead. And theoretically, defenders could design systems with built-in complexities or frictions that make automated attacks harder if they can keep pace.
But the general feeling, according to the material,
It suggests many experts feel the attackers currently have a slight edge, primarily because offensive tools, especially those leveraging public AI models, might be easier and cheaper to develop and deploy compared to building, training, integrating, and maintaining complex, enterprise-wide AI defense systems. But it's stressed that this balance is highly dynamic and can shift rapidly based on innovation, resources, and countermeasures.
and agentic AI is seen as the next major disruptor in this balance.
Absolutely. Autonomous AI agents represent a potential paradigm shift. Offensive agentic AI could mean coordinated swarms of AI agents, launching sophisticated attacks with minimal human direction, doing recon, finding vulns, exploiting, adapting, exfiltrating data, all on their own. Morse II was just a glimpse.
And defensively,
Defensive agents could collaborate across networks, autonomously identifying threats, containing them, patching systems, maybe even launching countermeasures. IBM's ADOM project is exploring this defensive side.
this sounds like it moves beyond just cybercrime into, well, cyber warfare and geopolitics.
Your sources definitely make that connection. AI in military operations could dramatically speed up decision cycles, potentially leading to rapid, unintended escalations, flash wars.
It also levels the playing field somewhat.
It democratizes advanced capabilities. Smaller nations or even non-state groups could potentially use AI to launch strategically significant cyber attacks, punching above their weight.
And creates new weaknesses.
Yes, these autonomous systems become high-value targets themselves. Hacking an autonomous vehicle swarm or a critical infrastructure AI could be catastrophic. And the AI models are targets too, as we discussed: poisoning, evasion, inversion.
Is AI being used for strategic warning too? Trying to predict conflict?
There's research into using AI to analyze global data for signs of impending conflict or geopolitical instability. But your sources note significant challenges remain getting enough reliable data modeling unpredictable human decisions. It's an emerging field.
So this AI arms race isn't just technical, it has profound strategic implications, demanding constant vigilance and adaptation.
Which leads us perfectly into the Infosecurity Europe 2025 section of your materials. This event is clearly positioned as a key forum for grappling with exactly these issues.
Right. The sources you provided really highlight it. It seems like AI isn't just a topic there in 2025, it's the dominant theme.
That comes through loud and clear from their pre-event info and their trends report. AI-driven attacks are apparently the #1 driver for cybersecurity investment now.
And GenAI specifically is the top perceived risk for nearly a third, 28% of professionals surveyed. That's huge.
It really highlights the immediate concern. And look at these stats. 78% of decision makers think AI demands a total rethink of security strategy. 71% expect more automation thanks to AI. And 80% say AI is now a regular boardroom topic.
It's definitely moved past the tech labs and into the C-suite and boardroom. People aren't just aware, they want practical answers.
Exactly. They want actionable insights on managing the risks, leveraging the opportunities, and knowing what concrete steps to take. And the events seem structured to deliver that. They've added a dedicated AI and cloud security theater.
A whole stage just for AI and cloud.
Seems so. Designed to cover both the threats deepfakes, automated phishing, LLM attacks, and the practicalities of securing your own AI and GenAI systems, especially in cloud environments, directly addressing that dual-use nature.
There's also a new area for channel partners, the channel zone.
Right. For resellers, MSSPs, integrators, keynotes there will focus on how AI is transforming their business, with speakers like Ian Thornton Trump talking about AI's impact and how MSSPs need to adapt.
And places for more direct interaction and advice.
Yeah, the InfoSec Hub with peer discussions and analyst clinics from Forrester, Frost & Sullivan, and the InfoSec Table Talks, small vendor-free roundtables for deep dives into specific issues like securing AI, identity management, consolidating security tools, and tackling implementation challenges.
And Sansa is doing masterclasses there now.
New for 2025. Intensive practical workshops on cloud security, security culture, likely with hands-on simulations. Importantly, your sources say these will integrate GenAI and ML training, very practical focus.
Looking at the likely discussion topics based on your material, deepfakes and AI social engineering are front and center.
Unsurprisingly, given the stats we saw, there's a keynote mentioned calling BS on AI with Andrea Isoni, focused on defense strategies. Expect discussions on the difficulty of detecting synthetic text versus maybe slightly easier detection of video audio, though that gap is closing.
And securing the AI systems themselves will be big.
Absolutely. Practical talks on defending against LLM exploits, data poisoning, prompt injection. How do you actually protect the AI you're deploying?
Examining automated phishing techniques?
Yes. Digging into how those attacks work and how defenses are evolving, and showcasing the benefits of using AI for detection and response, how early adopters are seeing improvements.
Some big-name keynotes, too, beyond the pure cyber focus.
Professor Brian Cox on science and complexity, Rory Stewart on geopolitics and cyber conflict, very relevant to the arms race, and Abadazia Sunsaid at the Women in Cybersecurity event.
And input from analysts and the UK government.
Forrester and Frost and Sullivan analysts discussing broader tech trends and human-centric defense. And the UK's DSIT covering national policy, secure development practices, AI risk management frameworks, and upcoming legislative changes.
This all sounds very focused on the now. What about regulations? The EU AI Act must be looming large.
It's definitely relevant, even if not every session is about it explicitly. Your sources quote Andrea Isoni again, saying, the Act helps organizations create risk-based plans by clarifying requirements and potential penalties. Its focus on high-risk AI systems touches many security tools.
So transparency, bias mitigation, human oversight, those requirements impact security AI.
Directly. And there's a policy roundtable mentioned with European and UK bodies, ECSO, NCSC, likely discussing how different regulations align or diverge. Plus, the DSIT sessions will cover the UK's approach. So expect compliance, ethics, and governance to be woven throughout many conversations.
Okay, so Infosec Europe 2025 seems like the place to be for understanding the practical reality of AI in cyber. Which brings us to the final part of your material, strategies for actually navigating this AI era. Actionable advice.
Right. This section pulls together the strategic imperatives, the core message. You need a holistic, proactive approach. Business as usual won't cut it.
Starting with that need to overhaul security strategies, 78% recognize this.
It means thinking risk first about AI adoption. How does it align with business goals? What's your risk tolerance? Using frameworks like NIST CSF 2.0 helps assess this across the board, enterprise, supply chain, third parties, and building security into AI development from the start, not bolting it on later. Security by design.
And embracing automation is non-negotiable.
You have to automate to keep pace. Integrating AI-driven tools for detection, response, even compliance monitoring is essential to counter AI-accelerated attacks. 71% expect this increase.
What about those board-level discussions? 80% are having them.
CISOs need to translate the technical AI risks into business language. What's the potential impact? How does AI security support business objectives? Your sources mention Gartner, emphasizing that CISOs need to secure how the organization uses and builds GenAI, especially as it gets embedded in everyday tools and security products.
And for organizations building their own AI, securing those systems is paramount.
Absolutely. Strong access controls least privilege, zero trust principles apply to AI assets, monitoring API usage, protecting the integrity of training data, and sensitive prompts used with LLMs.
Defending against those AI-specific attacks like prompt injection.
Yes. Thinking about secure deployment cloud versus local risks. Securing the development pipeline, using guardrails, input-output filtering for LLMs, continuous monitoring for model drift or unexpected behavior, and aligning all this with relevant governance frameworks.
Which frameworks were mentioned?
NIST AI Risk Management Framework, RMF, MITRE Atlas for adversarial tactics, the idea of an AI bill of materials, AI bomb for transparency, ENISE's framework. Using these provides structure.
So secure your own AI, but also prepare your general defenses for AI-powered attacks coming at you.
Right. Leverage defensive AI, actively predictive analytics, real-time detection, automated response, AI-assisted hunting. Keep up with proactive vulnerability management using AI to prioritize patching. Strengthen core network defenses, data protection, and monitoring.
Amidst all this tech, your sources circle back to the human element. AI isn't replacing people.
Not replacing, augmenting. That's the key message. AI handles the scale, the speed, the repetitive tasks. Humans handle the complexity, the intuition, the critical thinking, the ethical judgment. It frees up analysts for higher value work.
But roles are changing, and there's a skills gap.
A big one. AI skills are now top 5 for cyber roles, but there's a global shortage of nearly 4.8 million professionals. This demands new skills.
Technical skills, obviously, understanding AML, cloud security, data science, AI security risks.
Yes, but also, crucially, soft skills. As AI takes over routine tasks, problem-solving, collaboration, curiosity, and especially communication become even more vital. Interestingly, your sources note hiring managers might be underestimating the immediate need for these AI-related skills compared to others in the organization.
So the future is human-AI teaming.
That seems to be the consensus. Humans validating AI findings, overseeing critical decisions, handling ethical gray areas, developing and training the AI. Most people, 82%, are optimistic. AI will improve efficiency, but there are definite concerns too. 65% want more regulation for GenAI safety. 53% worry AI adoption brings significant risks.
Continuous learning is therefore essential for professionals.
Non-negotiable. You need to understand how to use AI defensively, how to defend against AI attacks, and how to secure the AI systems you deploy. Training providers like SANS are adapting, offering specific courses and integrating AML concepts across their curriculum, often with hands-on labs. Professionals need to keep learning and adapting.
Looking even further ahead, what does the material suggest is coming next?
A few things stand out. The near-term expectation, maybe starting in 2025, is the rise of multi-agent AI systems and more autonomous operations. Think offensive AI agents coordinating attacks with little human input. DARPA's AI Cyber Challenge points towards AI finding and fixing vulnerabilities autonomously at scale.
That's quite a leap. And quantum computing.
That's a longer-term horizon, maybe 2030, 2040, according to the sources. The threat is that quantum computers could break current encryption standards, requiring a major shift to post-quantum cryptography, PQC.
NCSC is aiming for 2035 for PQC completion.
That's the target mentioned. While quantum might not directly break AI algorithms in the same way, if the underlying cryptography protecting AI systems and data fails, it's a huge problem. WEF flagged quantum and AI as disruptive way back.
And underpinning all this future tech are ethics and governance.
A massive challenge. Issues like privacy, AI needs data, algorithmic bias, AI learning societal biases, accountability. Who's responsible when an autonomous AI messes up? There's a real tension between security imperatives and individual rights.
What's the path forward there?
Clear guidelines on data use, regular bias audits, diverse stakeholder involvement in AI development. Frameworks like IE's ethically aligned design provide principles like prioritizing human well-being and ensuring transparency and auditability.
And regulations are trying to enforce this?
Increasingly. The EU AI Act is the big one currently, with its risk-based approach. But also DORA for finance in the EU, NIS2 for critical infrastructure, CMMC in the U.S. defense sector, the global ISO IE SORTI 2001 standard for AI management. These are forcing organizations to take security and ethics seriously. The advice is agile governance, privacy by design using privacy-enhancing tech, and staying on top of global changes.
Your material apparently wraps this section up with a handy table of actionable advice.
Yes, a good summary, pulling together those key steps for businesses and professionals trying to navigate this complex landscape.
Okay, let's try and synthesize all this. If you had to boil down the main message from all the sources you provided, what would it be?
I think the core takeaway is that AI is now a fundamental, transformative, and permanent part of the cybersecurity landscape. It's not optional anymore.
And it's profoundly dual use, a weapon and a shield.
Exactly. It empowers attackers, making threats faster, bigger, sneakier. But it also empowers defenders with unprecedented capabilities for analysis, prediction, and automated response. This constant tension is driving that relentless innovation cycle, the arms race.
So complacency is not an option. Proactive strategies are essential.
Organizations have to assess their security in light of AI, invest in securing their own AI deployments, and actively leverage defensive AI to counter the evolving threats.
And for individuals, it's about continuous learning and skill development.
Absolutely paramount. Understanding AI, its risks, its benefits, how to work with it safely, that's crucial now. And woven through everything is the need for ethical considerations. Privacy, fairness, accountability backed by robust governance, and adherence to emerging regulations like the EU AI Act. Responsible innovation is key for a safer future.
We really hope this deep dive, built entirely from the material you shared, gives you a solid understanding and empowers you to engage confidently, whether you're heading to Infosecurity Europe or just dealing with this day-to-day.
Understanding AI's impact really is the critical first step on this cyber battlefield that's changing faster than ever.
Thank you sincerely for providing such rich source material. It's made for a, well, pretty intense but fascinating exploration.
Absolutely. And maybe here's one final thought, something for you to chew on based on everything we've discussed from your sources.
Go on.
With this accelerating AI arms race and the real possibility of autonomous AI agents making decisions and taking actions at machine speed on both sides, how do we genuinely ensure that human oversight, ethical judgment, and essential control mechanisms can actually keep pace? Can we keep humans meaningfully in the loop when things are moving that fast?
That's a big question. Definitely something to think about further. We hope this discussion has been valuable.